In this module, you've explored the techniques of formal logic and logical reasoning. We will now use the applied reasoning strategy of problem solving to solve an interesting little logic puzzle. Let's take a look. Our puzzle gives us the information that 6 girls, Sarah, Tracy, Ursula, Vera, Wendy, and Zara, each play at least one of 3 sports: rugby, tennis, and volleyball. We're then given a number of conditions, the bulleted list below. Take a moment to read through this list. As you read through this list, see if there are any statements that you can translate into formal logic in order to better understand the puzzle. I found 2 that are easily translated to formal logic. Sarah plays no sports, Wendy plays is the first of these 2. We can write this in if-then format as shown here. If Sarah plays a sport, then Wendy does not play the sport, because Sarah and Wendy play none of the same sports. We also know that the contrapositive is true. If Wendy plays a sport, then Sarah does not play a sport. Recall that you find the contrapositive by switching the left and the right sides, the if and the then, negating each side, and then changing any ands to ors and vice versa. There are no ands and ors, so all we had to do here was swap if s then no w to if w then no s. See how we both reversed and negated? Now our second formal logic statement can be found here. Ursula and Sarah play no sports in common. This is essentially the same statement as the other statement about Sarah and Wendy. Playing no sports that Wendy plays is basically the same as saying that Sarah plays no sports that Ursula plays. So, we can rewrite in the same way. If Ursula, then no Sarah. If Sarah, then no Ursula. Now, we've simplified this a little bit by translating into formal logic, but there's a lot more work to do in order to fully understand which sports each of the girls plays. When we're using logical reasoning, it's often helpful to try to organize our thoughts. In order to do so, we can create what's called a schematic, shown here. This basically is a diagram that summarizes all of the possible information and all of the information that's given in the conditions. So we see we have our 6 girls, Sarah, Tracy, Ursula, Vera, Wendy, and Zara, and our 3 sports. We're trying to figure out which sports each girl plays, so we can apply the conditions by putting X's in boxes where there's not a match. In other words, if we put an X in the Sarah rugby box, that means Sarah does not play rugby, and open circles, or O's, when there is a match. So if Sarah plays tennis, we would put an O in the box that corresponds to Sarah and tennis. Let's apply each of our conditions and place them in this box as much as possible. Let's look at our first condition. Vera and 3 others play rugby. Now we know, therefore, that Vera plays rugby, so we put an O in that box. But there's not much we can do about the 3 others right now. We don't know which ones they are, and there's not really a clear way to demarcate which girls might play rugby. So we'll just leave this statement at the top of the schematic and hold on to it for later. As we fill in more information, this might be useful and help us to further specify our situation. Let's look at our second statement. Wendy plays tennis and volleyball. So we know that we should put an O in the Wendy tennis and the Wendy volleyball boxes. We don't know anything about whether Wendy plays rugby. On to our next statement. Sarah plays no sports that Wendy plays. Now let's think about this for a moment. If we have Sarah, then we don't have Wendy. Or if we have Wendy, then we don't have Sarah. Wendy's already in the diagram. We know that she plays 2 sports, tennis and volleyball. So that means Sarah doesn't play tennis or volleyball, which means that Sarah could play rugby. Now we know that each girl has to play at least one sport. So since Sarah can't play tennis and volleyball, she has to play rugby. And based on our statement here, if Sarah, then not Wendy. So we know that Wendy doesn't play rugby. So with just 3 statements, we've already filled out a large proportion of our schematic here. Let's move on to our next statement. Zara plays more sports than Wendy. Well, we know at this point that Wendy plays 2 sports, tennis and volleyball. If Zara plays more sports, she has to play 3 sports because that's the maximum number of sports, so she plays all of rugby, tennis, and volleyball. Simple enough, and now we've filled in more than half of our schematic. Pretty nifty. Now we're back to our next logical reasoning statement. Ursula and Sarah play no sports in common. Well, this means that we know that Ursula cannot play rugby because Sarah plays rugby. However, we also remember, looking back at our old statement, that Vera and 3 others play rugby. Well, we've decided that Ursula and Wendy cannot play rugby, and that Vera does play rugby, which leaves only 3 others, Sarah, Tracy, and Zara. We knew Zara played rugby already, so we now know that Tracy also plays rugby. So we've used up this statement as well. We're also given that Tracy plays 2 sports. So we know that she plays rugby, which means she must play one of tennis or volleyball. We don't know which, though, so we'll just hold on to this condition. We're also given that only 2 people play volleyball. So we know that Wendy and Zara must play volleyball because that was already demarcated. And since only 2 people play it, we know that none of Sarah, Tracy, Ursula, or Vera plays volleyball. We also knew that Tracy plays 2 sports. We knew she played rugby, and since we know she can't play volleyball, she must play tennis. So now we only have one question left. What does Vera play? Since we've used up all of our conditions and can't further specify the problem, we can't tell whether Vera plays tennis or not. But we were able to very quickly determine most of the sports that most of the girls play by using logical reasoning and the schematic to quickly organize our thoughts. If we think back to the information we were given, 6 statements that related maybe 1 or 2 girls to each other or to a sport at a time, this schematic helps us to uncover all of the relationships between the girls in the sports. For example, we can say 4 girls play rugby. We can also say that only 2 play volleyball. We can determine who plays sports together. Wendy and Zara play 2 sports together. Zara, Sarah, and Tracy each play rugby together, but Zara plays more sports with Tracy than with Sarah. So we can pull off even more logical reasoning statements using this schematic. A lot can be deduced here. And we can see the power of using logical reasoning in a schematic to solve problems.